Hi students, this is Lakshmi Pallavi, Assistant Professor of Mathematics in BSH Department from B.V. Raju Institute of Technology, Narsapur, and my course name is Linear Algebra and Calculus, and I will be telling you about matrices today. Actually, when we talk about mathematics, the one thing which comes into everyone's mind is what? It is numbers. Numbers are the basic thing which we learn even from our childhood. Yes or no? So when you're in your childhood, you will be learning 1, 2, 3. Yeah. So and then we have learned 0, that is 0, 1, 2, 3. Then we know there are negative numbers, positive numbers along with 0. Yeah. This is natural numbers. These are whole numbers, these are integers, and we have many kinds of numbers, right? And then we have rational numbers. Yeah, rational numbers which are of the form p by q, where q not equal to 0. Yeah. And then we have real numbers, we have irrational numbers. What are irrational numbers? Root 2, root 3, root 4. All these are irrational numbers. And then we have real numbers. And also we are not satisfied. And then we went with complex numbers. What is a complex number? A number which is of the form a plus ib, where I is a complex number and I square is equal to minus 1. So like this, we had many kinds of numbers since our childhood which we were learning. And as we are going on learning with the numbers, finally, one day, I have seen the numbers all these days during your childhood, we were writing them in a single row or in a single line. All the numbers we were writing in a single line, right? But suddenly, someday, I've seen my lecturer telling me writing the numbers in a box. Yeah, we have started writing numbers in a box, and also not only in a straight line, we were writing them like this in rows and columns. Something like this. What is this? Yeah, this is a matrix. So, writing numbers in a straight line itself is a bit difficult. Then why are we actually writing numbers in rows and columns, and then why are we calling it as a matrix, and then we are doing many operations on matrices. So why actually are we studying matrices? What is the main use of studying matrices? Matrices are studied from your 10th or intermediate because they have very wide range of applications. See, when you go to a railway station or an airport or any bus station, there you will see how the departure of the trains and the arrival of the trains, everything is displayed on a display board. Yes or no? So in the display board, when you see, it is written in rows and columns. So the basic concept is coming from where? It is coming from matrices. And these days, all of us use WhatsApp, right? In WhatsApp, whenever you send a message to somebody, what is seen on the top? End-to-end encrypted. What do you mean by end-to-end encrypted? See, a computer or a system, what it will do is, it will store the data. Whatever data is given, it will store in the forms of ones and zeros. So, whenever any data we are giving to the system, or whenever you are typing any message, what the system will do is, it will convert your message into a machine language, and then it will be converted into ones and zeros, and then it will be given to the it will be sent to the receiver to whom you have sent the message. And there, the receiver, at that end, the message will be decrypted, and that message will be read by the other person. So whatever data you are sending, it is safe. Nobody can check what you have sent in the middle. So in WhatsApp we are using it. So the basic thing or the basic computer is using all the data, or every data in a system or in a computer is stored in the form of a matrix. Always a computer stores your data in the form of a matrix. So in the form of ones and zeros. That is the reason we have many more applications of matrices. In electronics also, all the electrical networks or the characteristic flow of the electrical currents, all these is studied using matrices. In probability and statistics also you will be studying about matrices, wherein we have a beautiful concept called Markov chains, in which each chain is represented in the form of a matrix. All the binary trees are represented in the form of matrices. So in civil engineering, about the in civil engineering, in the motion of the rigid bodies is studied with the help of matrices. Not only this, we can convert. See, whenever you have a 3D picturization and you are watching all the 3D picturization on a screen as a 2D picturization. So the 3D picturization to 2D picturization is also taken care with the help of matrices. In animation and in coding, in robotics, in stock analysis, mention not, in each and every place we are using matrices, because the general form of writing a matrix is this. So this is actually, when you go to a system, this is called as an array. It stores the data in the form of an array. So let us go with the formal definition of a matrix. Let us start with the formal definition of a matrix. A matrix is a system of, it is a system of m numbers. It is a system of m numbers arranged in rectangular form of m rows and n columns. M rows and n columns. And always a matrix is represented with a capital letter, and the elements in the matrix are represented with small letters. Okay, so this is A equal to Aij. Suppose you have a matrix like this. A equal to 1, 2, 3, 4, 5, 6, some 8, 7, 9, something like this. So this is a matrix wherein the order of the matrix is given as m by n. Here also you can write m by n. The order of the matrix is given as m by n. So m by n, where m represents the number of rows and n represents the number of columns of the matrix. So here this is a matrix of order 3 by 3. So what is order of the matrix? Order of the matrix will tell us how many rows and columns are present in any given matrix. So this is a matrix of order 3 by 3. So then if the number of rows is not equal to the number of columns, then we call such a matrix to be a rectangular matrix. We call it as a rectangular matrix. And if number of rows is equal to number of columns, then we call such a matrix to be a square matrix. We call such a matrix to be a square matrix. So the matrix which I have written just now, it is a square matrix in which the number of rows and the number of columns are equal to each other. Then we have a row matrix. Row matrix is a matrix in which there is only one row and you can have many number of columns. So this is 1 by n. Okay. Then you have column matrix. Column matrix is a matrix in which there is only one column and rows are many. That is m by 1. So we have a row matrix, we have a column matrix. And then we have unit matrix. Okay. Unit matrix in which the numbers are 1. And then we have a null matrix. Null matrix is a matrix in which all the elements are zeros, or we call it as a zero matrix. And then we have diagonal matrix. See, here when you write a matrix like this, here this element 1 is represented as A11. That means it is present in the first row, first column. It is called as A12, A13 like this. Okay. So when the row number and A21, A22, A23, A31, A32, A33. When the row number and the column number is equal, then that is called as a diagonal. We can have two diagonals, ma. This is one diagonal and this is the other diagonal. But this diagonal in which the row number and the column number is equal, such a diagonal is called as principal diagonal. It is called as principal diagonal. Okay. And a diagonal matrix is a matrix in which only the diagonal elements are present and other elements are zeros. Only diagonal elements are present and other elements are zeros. Such a matrix is called as a diagonal matrix. Then we have scalar matrix. Scalar matrix is a matrix in which the diagonal elements are same. If the diagonal elements are same, then such a matrix is called as a scalar matrix. Scalar matrix is a matrix in which the diagonal elements are same. Then we have equal matrices. Equal matrices. What do you mean by equal matrices? We say that two matrices are equal if their order is same. First, order should be same. And second, every element of first matrix should be equal to every element of the second matrix. Every element of the second matrix. Every element of first matrix should be equal to every element of the second matrix, including its position. Okay, then only we can say that two matrices are equal to one another. And also we can have addition of two matrices. You can add two matrices. The condition is same. First, order should be same. And then every element, corresponding elements are added. Suppose you take like this. This is one matrix and this is one more matrix. Then first you check the order of both the matrices are same. Then we add the corresponding elements. So 2, 0, 2, 1, 2, 1, 2, 2, 3, 5, 2, 7, 6. So like this we can add two matrices. Similarly, you can subtract two matrices. You can also multiply two matrices, but we cannot never divide two matrices. Yeah, we can add two matrices, we can subtract two matrices, we can multiply two matrices, and we cannot divide two matrices. Then the next matrix which we have is trace of a matrix. Trace of a matrix means adding the principal diagonal elements. Suppose you are given a matrix like this, then trace of A, this is a matrix A, then trace of A is 3. So when we add the principal diagonal elements of a matrix, we get trace of a matrix. Trace of a matrix. Then you have triangular matrices. In triangular matrices, we have two things, that is upper triangular matrix and lower triangular matrix. upper triangular matrix and lower triangular matrix. So, in upper triangular matrix, the elements which are below the principal diagonal are 0. That means you will be having elements on the upper side. Okay, like this. This is a upper triangular matrix. The elements which are below the principal diagonal, those are zeros in upper triangular matrix. In lower triangular matrix, the elements which are above the principal diagonal are 0. 1, 0, 0, 2, 3, 0, 4, 5, 6. So, it is a lower triangular matrix. The elements which are above the principal diagonal are 0. So, this is an upper triangular matrix and a lower triangular matrix. Then we have idempotent matrix. Idempotent matrix means A square equal to A. We call a matrix A to be an idempotent matrix if A square equal to A. Then we have nilpotent matrix. Nilpotent matrix means A power m equal to 0 and this m is called as index. M is called as index. A power m equal to 0 where m is called as index, that is called as a nilpotent matrix. Then we have involutory matrix. In involutory matrix, A square equal to I. In involutory matrix, we have A square equal to I. Then the next thing which we see is transpose of a matrix. Transpose of a matrix means interchanging the rows of a matrix with its columns is called as transpose of a matrix. So, suppose A is a matrix, then its transpose of A is represented as A power T, A transpose or A dash. A transpose or A dash, wherein we will interchange the rows and the columns. Suppose this is the matrix A, then A transpose will be like this. Here, when we interchange the rows and columns of a matrix, then such a matrix is called as A transpose. And then we will see symmetric matrix. If A transpose is equal to A, then we call such a matrix to be symmetric matrix. Then we have skew symmetric matrix. Skew symmetric matrix, A transpose equal to minus A. Whenever A transpose is equal to minus A, we call such a matrix to be a skew symmetric matrix. And then we have minors and cofactors. Okay, and then we have minors and cofactors. See, what is a minor? Minor is the determinant of n minus 1 row matrix is called as minor. Now first, what is determinant of a matrix? Suppose you have a 2 by 2 matrix like this. Suppose this is a 2 by 2 matrix like this. Then determinant of A is given as AD minus BC. Determinant of A is equal to AD minus BC. Then here, minor means it is the determinant of n minus 1 row matrix. Suppose you are calculating minor of an element. We are calculating minor of 1. Minor of 1. Then we remove the row and column in which this 1 is existing. So, where is number 1? It is in the first row, first column. So, we remove the first row and first column. And whatever is left out, we take the determinant of 5, 6, 8, 9. This is minor of 1. So, what is minor 1? Determinant of the n minus 1 row matrix is called as minor. Then we have cofactor. Cofactor is nothing but it is a signed minor. Cofactor is signed minor. So depending on the position of that element, we will take whether it is giving us a plus sign or a minus sign. So that is -1 whole power I plus j. So you see 1 is where it is in first row, first column. So what is its sign? -1 whole power 1 plus 1. So it is plus 1 is the cofactor. So cofactor along with the determinant will give us, it is a signed minor. Minor along with the sign will give us cofactor. So suppose if you find determinant of this, what is this? 45 minus 42. So that is -3. So 48. So it is -3. So signed minor, that means plus -3. This is the cofactor of 1. So minor is determinant of n-1 row matrix, and cofactor means giving sign to the minor is called as cofactor. And then we have A inverse. A inverse is adjoint of A by det of A. And what is adjoint of A? It is transpose of the cofactor matrix. Transpose of the cofactor matrix is adjoint of A. So A inverse is adjoint A by det A. And if inverse exists, we call such a matrix to be a non-singular matrix. Yeah, non-singular matrix and singular matrix. If det A equal to 0, then we call such a matrix to be a singular matrix. And if det A not equal to 0, then we call such a matrix to be a non-singular matrix. Yeah. So this was all about matrices and its introduction. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.